current policy, but nothing is as strict as in Germany. Well, you were playing with an axe without my supervision. That's what's happening. um, you know, we probably had this kind of talk with one of your friends, like, we should buy a bar, right? So you're sitting with someone, drinking a beer, and then, awesome idea, we should buy a fucking bar. Of course we should buy a fucking bar. Why didn't I think about it earlier? Or you're riding a street with your awesome, fabulous 100 horsepower car, and you see a Porsche, and you say, fuck, this will be my new car. And yet, after a while, you buy a Volkswagen. Because, you know, it was my choice, not that I had to. And, you know, the same actually happens all the time with customers, with business. We had a customer who wanted to do the best possible logical replication from Oracle database to PostgreSQL. So they prepared all the requirements. We read the requirements. We said, awesome. We will prepare you an offer for a golden gate. So we sent an offer for a golden gate, and they laughed so fucking hard when they saw the price. Because it has occurred that they have 2-node real application cluster, standard edition 2, and a price for a golden gate was their whole IT department. And even more, they could buy another IT department. So they asked us, is there any open source tool we could use and just, I don't know, pay support? We're like, no, come on, shit. There's nothing stupid enough to write a tool for logical replication, make it open source, and just sell support. And when I said it, my friend, partner in my company, said, well, we are stupid. So after a few beers, after deciding that we are not going to buy a bar, but we want to do something else that is also stupid, we said, let's write an open source replication tool, put it there on a GitHub, and just sell support. Nothing exists like that. It will be cool. Let's do it. Yeah, let's do it. So we open Hex Editor, and you know how it is. You know how? Have you seen this drawing? How to draw an owl? You know, it's draw some circles, draw the rest of the fucking owl. So we opened a Hex Editor, and we're like, okay, shit, we have some circles. What next? So after a year, day by day, sitting with fucking Hex Editor and recognizing patterns and passing redo logs, we finally have something that actually works. And we just finished 2 technical POCs. And we are right now in the middle of tests with business, and if everything will be great, if everything will work, the sources will be on GitHub by the end of the vacation. So using knowledge, okay, this is the architecture of VOODOO. Why we called it VOODOO? Because it was fucking black magic to understand how redo logs work. And we drank a lot of vodka to actually process it. You can't sit sober against hex editor. Fuck, it's impossible, you know? So the architecture of VOODOO is actually pretty simple. It's pretty and simple. It will be appliance. Well, it is an appliance. So you will be able to start a virtual machine or install it on normal machine and set up network connections to the source, to the target, set up everything in Apex, click play, and 3 processes for each replication will start. It is catcher, parser, and applicator. So catcher is connecting to the outbound server, so to the source server, is grabbing a redo stream, is removing some garbage from redo stream, a lot of garbage in redo stream. I will tell you what garbage later on. And create something we named a record files. Then a record file is a clean, nice, neat form of something like archivelog. And then parser is parsing this binary file and is producing something called DML files, another binary file with actual logical transactions. And then after a commit, applicator is taking the DML files and applicated them to the other side. So during this tremendous, fucked up work, we learned a lot of cool things. And actually, I don't want to talk too much about the tool itself, because when it will be there, it will be there. You will see how it works. But I want to use it to show you some cool stuff about redo logs and transactions in the database, and some general thoughts about programming, Python, and other bullshit. So, we chose Python. Okay, we chose Python to write this. Why? We had to write it fast enough, and performance was good enough. But right now we decided to rewrite everything for the 3rd time. First time it was really fucking too slow, so we had to understand bytecode of Python, disassemble all our Python code, search the bytecode of Python, understand how Python virtual machine works, and optimize, for example, my parser, because I was responsible directly for the parser. And the optimization was, okay, this is bullshit, throw it away, start again. But it was worth it. It was working from 30 to 100 times faster, depending on the amount of transactions and the data types. But right now, we came to the conclusion that slowly, when it will work slowly, we will start to rewrite everything, possibly with Golang. A little bit more complicated, but fucking fast. So, to understand how transactions and redo actually works in Oracle, you have to understand that redo record is like beer. Okay? So we will make one simple visualization here. I will be a log writer, and you are all here, database through redo log block. So your size is 512 kilobytes, okay? And I, as a log writer, am putting redo records to you as a block, and then you will be pushed to the disk at the end. So if redo is like a beer, let's talk about the beer, about the redo, and let's try to understand what is change vector based, for example, on update. Let's say that I had polar monkey, cool name, amber lager. It was my first value, okay? And then I want to change a value, so I perform an update, and I want to change it to India Pale Ale. What's going on the redo, in the redo record? First of all, if you have supplemental logging turned on, which is mandatory for any logical replication to run, you have to know that one redo record can contain only one change. So if you are changing 6 rows, you will have 6 redo records with similar construction. And this redo record would look like this. Isn't it pretty? So there will be some headers and descriptions and so on. And you will have one change vector in the redo record which contains previous value, so my original amber lager, and the other one will be change vector with actual update, so India Pale Ale. So this is undo, and this is actual change combined in one redo record. So this redo record actually, since this redo record contains undo, undo table space actually has these change vectors. So undo table space as a table space contains the values like extracted binary from redo and put into database blocks to undo table space. And all undo information is in all redo. Here, between those two change vectors in the redo record, you will find in between supplemental logs. So when undo change vector, marked internally as opcode 5.1, when this redo record, when this change vector ends, you have supplemental log data for update. So for example, if you say that your supplemental log data is primary key, I will have here a value of primary key for this change, and then the actual redo, and that's it. And you just have to parse it. Simple, right? So when I do perform a commit, redo record has to be put into a database block. Redo record block, which is 512 bytes. I said kilobytes at the beginning, right? Bytes, 512 bytes, half a kilobyte. Sorry for that. So your size of this room is 512 bytes. And for example, if I will do only this one change and perform a commit and write somehow to you a redo record, your whole block is being put on disk with one redo record, 2 change vectors, but everything else is empty, right? You're sad, aren't you? So you are sad empty spaces. You are zeros. So the rest of the block is empty. So this is something that we want to cut off, for example, with a catcher. I don't want to store in the appliance and transfer empty bytes, right? So the catcher cares about extracting only redo records and cut off everything else. And if your application is doing a lot of commits, a lot of very, very, very short transactions, you will have a lot of redo that is empty and sad. And this is recorded in Oracle, since Oracle has fucking a lot, instrumentation and statistics and wait events, and this is cool because you always know what's going on. And this is recorded in Oracle as a redo wastage statistic. So, well, too long transaction, not very good. Too small transaction, you see how sad you are. So the best thing would be, for example, to pack more change vectors into one in one go, right? For example, like this. I can't make everyone happy. Okay, so I'm putting this. Can you pass here? Anyone? Someone? Okay, I will go there. So I'm putting more and more data into blocks. So as you can see, larger transactions can be better, but they will produce more and more. When they will produce more and more data, for example, if I would have a lot of like a truck of beers, they would scatter across many blocks of all the rooms. Everyone would be fucking happy. But then the rollback, sorry, I'm getting thirsty. But then the rollback would be really, really, really dreadful thing. So, oh. I'm sorry for that. So let's do it like this. So what's going on the database level when I start a transaction? Sorry, 3 slides this time. Better than last time, I had 2. So I have, for example, here a pretty little session, and I will start a transaction. So I'm producing update HR. Let's go here, it will be easier. Update HR employees set last name dupa where, for example, department ID 120. Okay, nothing. Maybe 3C 120 20. Okay, 2 rows updated. What has happened? Well, oh, sorry. Shit, what's going on? Fuck. Better? Yep, okay. So what has happened? First of all, the database block was read from a disk to a memory. In a redo log, there were produced how many redo records? At least 2 redo records, each containing at least 2 change vectors, right? Because I want to have undo and so actual last name and dupa as new true name. S. So, here, after starting this transaction, something called xit was allocated. So xit is a unique ID of a transaction that was allocated, and allocating a new xit is also another change vector. That's why I said that each of those 2 redo records will contain at least 2 change vectors, one for undo, one for redo, actual, and one of those redo records, the first one, supposedly, will contain a change vector that is allocating this new xit. And this will be, so I will have change vectors like 5.2 allocate transaction, 5.1 first undo, 11.5 first update, and this is first read record. And the other one will be 5.1 undo, 11.5 redo, and that's it. And transaction is going on. In memory, I have here memory mapped files by /dev shm, so I'm using memory target, and don't do it, this is pure shit. But for the purpose of showing this, in the memory, I can find these database objects, the database blocks that were affected by this transaction by looking through memory and searching for XSEED and data object ID of a block that has changed. So each block, those two rows were in one block. I have one changed block. I can go here. And this transaction mm-hmm, 09 18 09 18 and 800 where is it 09 can be first, no, can you see it? Am I so blind? Here it is. Okay. So in each database block, you have something that something like structures that contain transactional information, and those structures consists of two other substructures. First is a structure containing XSEED. So this database block, I have information, was changed by XSEED that consists on undo segment number 9, slot 1800 in hex, and sequence number, you can see it. If you combine it, this is this XSEED, right? And then this database block for this transaction contains something like UBA, undo block address. So this is information that in a file, in a specific block, in a specific record in this block, is stored undo, so change vector 5.1, which will be used to roll back data if I will hit roll back. Okay? So when I want to roll back data, I get this ID, go to an undo table space, get a transaction with previous value with something that was before DUPA, and then change the value to a previous one and set pointer to other UBA with another undo from other read record. And I'm linking this, linking during the rollback until I'm finishing a rollback and finishing rollback with actual commit. So short transactions, shit, very long transactions, very long rollbacks because of this linking, changing, linking, and commit. Everything is bad. Just don't use transactions. And when we are passing the whole redo log stream, we come across some things that should be basic for developers, but we long forgot about it because frameworks made us lazy. So, for example, we are parsing a redo log, and we came across a situation that, for example, in a redo log, you have information, this change is 5 bytes long. So you read 5 bytes, right? and something should happen already after this change. But instead of having data right after the change, we have zeros filled, for example, up to 8 bytes, and then another change. So a lot of time in the code, you have to do something like this. If something modulo 2 is not equal to 0, then add another offset. Why is this happening? In memory, for a CPU, it's normal. If you program in Python, in C, in Java, and you are parsing on writing to a binary file, you will see that your structures are not exactly the same as you can see in the binary file at the end. Because there's something called data type self-alignment. So, for example, integer can start in memory or in a structure only in memory address that is a multiplication of the size of integer. So since integer, for example, is 4 bytes, can I start at byte 1? No, I can start at byte 0, 4, 8, and so on, and so on, and so on, and so on, right? So for example, if you are creating even a structure in a high-level language, like Python, so you are doing something like this, and you want to create a structure that contains 1 byte, 1 integer, 1 long. So byte has 1 byte, integer has 4 bytes, long has 8 bytes. How long the data size should be? 1 plus 4 plus 8? Yep, yep. So I heard something good. So for example, if I did dupa pack 1, 2, 3, whoa, and check the length, I will get 16 instead of 11. If I would change the order of a sequence, of a structure, so Q, E, B, and then check it, I would get appropriate size like 13. So all the time when you are, for example, parsing a binary files, and you will see that some things end with bunch of zeros and then start another, you see another data, it fills up with data and a few zeros and another data and a few zeros. Well, it's something called C-structure packing and alignment, because the whole structure also can start only in a multiplication of the longest data type in this structure. Did I say it right? Did you understand me? I'm not sure I understood me. Let's drink some elixir. So combine all this together, you can start a journey for parsing read log. And in debug mode, you will see what exactly is going on each for each and every step. So this is almost like dump of a redo log. So as you can see here, we have a redo log block from sequence 57 from block 6192, and this redo record started in some offset in the block, and this all combined together is creating a redo block address, RBA. Most of you should know that SCN and RBA are two numbers that are very important for controlling versions and transactions in Oracle. So this redo record here was validated and is correct. That's why we have it here. We can parse it. And we found opcode 5.1. 5.1, as I told you before, is an undo. In undo, I found object ID and data object ID for change I want to parse. At the end, of change vector with undo, I found supplemental log data and started to build actual update based on change vector 11.5 here. So this is an update. Column that was changed was last name. Supplemental log data consists of 3 bytes. And at the end, I got my change. This change was written to a DML file that contains ID of a transaction in the name. So this is disk seed we found in here, and the seed that is combined, of course, with database block and with undo to perform a rollback. So when I will commit this transaction, so the transaction will be ended, so the exit no longer exists. Oh, sorry. The exit no longer exists, and commit is another change vector which actually clears everything from undo tables, removes the transaction, and at the end, after passing it, the name of a file has assigned SCN of this commit, and the name is changed to committed. This is a transaction file that will be used by applicator to apply changes to another to the target, to another database. So I can check. We have support tools like in Oracle Exadata. Show DML file contents. You can see logical statements that will be used by applicator, and the order in which they will be applied. First is SCN of actual read record, so another change number of the read record, and a sequence of a change. So this SQL will be applied first. This SQL will be applied second. After starting an applicator, which is another process here, the applicator will get the file, execute everything from a file, and as you can see, will remove it. And on the target database, which is called Rico, and I think it was a pluggable database. Yep. Container kaboom. It was 20, right? We have dupa. So this is how it works. And the funny thing happens, for example, in Oracle, when you will violate a constraints. When I told you that short transactions are not good because they cause a lot of read wastage, because you were set blocks with no BS, right? And I told you that rollbacks are not very, very good, right? So let's see what is actually happening when I will try to do an update which violates a constraint. Because sometimes we use, well, constraints just as logic in our application to validate everything without any pre-validation. So let's see what will happen. I will do update HR employees, set employee ID equals, for example, 100, right? Naruszono więzy unikatowe, right? So unique constraint violated. Let's see the log of my parser. Let's check what happened. So seed for this transaction was like this, okay? So I will go through each and every transaction. Check this out. Oracle actually generated 1, 2, 3 changes to the rows until it realized, fuck, something's going on. I can't set another value because this is a unique constraint. I'm updating an index in the meantime because I have to, and I found that this key already exists, so I have to throw an exception. And when exception rises, that naruszono więzy unikatowe, so a unique constraint violated, we will find a rollback. Found rollback code for HR employees. And this is 1, 2, 3 rollbacks. So all those values were applied, and then all those values were rolled back. And since this was the beginning of the transaction ended with implicit commit that is finishing a transaction, so you won't see a trace, like you won't see nothing right here in $v transaction because the transaction started, rolled back, the end. The other the other way would be, for example, to start a transaction. Let's be generous, right? And then perform something that violates a transaction. Right now, I can't finish a transaction and remove seed because I started something previously. So this will be a partial rollback. So some of those changes actually happened. I have active transaction here. I can find it in my log. It will be a lot. But I will find also information that I have 3 rollbacks for disk seed. Now, when I will commit it and finish the transaction, oh, fuck, sorry for that. I have to stop applicator because it already managed the file. So, shut down. Stop it. Yeah, stopped. So let's do it again. Update salary, update employee ID, commit. Okay. So the same situation. This is my candidate file. This is my this right now it's committed. So I will see in DML file contents three rollbacks that will remove three previous statements that are not correct, right? So if you are not using, for example, if you're using constraints for validating your data, and well, that's good because constraints are awesome and you should have them. But sometimes it's much better, for example, to write something to pre-validate your data before putting them into your database. Because each and every time you are violating a constraint, you are doing rollback, commit, redo wastage, set blocks, set database, pissed off DBA. So if a DBA, for example, will tell you that I can see in AWR or StatsPack that your application or your process is doing fucking a lot of rollbacks, you will say, I'm not doing rollbacks. Then think that maybe you are doing implicit rollbacks because of constraint violation. And you have to add some another code, for example, to pre-validate the data. It might be faster. Oh, come on, don't start with that. I'm telling about some kind of pre-validation, not being... I know that. No. So what I'm actually trying to say is that trusting in any kind of framework, technology, or anything that will always do something very good for you automatically, automagically, without your knowledge, without your without trying to understand what's going on at the low level, is not a good idea. Because as Pratchett wrote, real stupidity beats artificial intelligence each and every time. And I think that's it. Thank you.
If you have questions, please raise your hand. I will give you the microphone.
No, I don't have another beer, sorry.
So how do you read the redo logs? Because they might be stored in ASM.
Yeah, funny thing that you ask, because currently we are supporting only ASM. It's very, the customer had the data on the ASM. We didn't finish yet a model to read it remotely from file system. And ASM is trivial because you are creating a user at the ASM level. You are connecting from a database. Catcher is connecting to the ASM instance, and it's using the same package Golden Gate is using. So it's called DBMS group. It's some kind of hidden ASM package that lets you to read. Where are instances? Here are instances. As you can see, I have 2 database instances and 1 ASM instance, and Catcher is connecting and using this hidden package that is using also Golden Gate to retrieve over over TNS, over regular connection database blocks. Next step will be to add an agent. I also don't need to hold anything.
I have a question regarding the tool. Like, what was the first reason you need to actually dig through the logs? Because you have something like LogMiner. At the end, you still need just a...
Yes. So we started with LogMiner to check if we can use it in real production environment for replication. And the first case was to use LogMiner. Well, LogMiner is not a tool for replication. It is a tool for audit. And LogMiner is passing all the redo logs when you go through them like byte by byte and so on. It retrieves everything. And it's fucking slow. It's too slow to use actual replication based on LogMiner. So we had to write our own parser for the redo logs. And the second reason was my idea of replication appliance was to ignore as little as possible on the source and target databases. So in ideal situation, you won't have to install any agents and nothing on the source database, just define a connection here and click play. So those were 2 reasons.
Yeah, you mentioned also missing pieces in LogMiner. What were these?
LogMiner is not in not all situations. LogMiner processes correctly blobs and lobs, and the customer had a lot of CLOBs, BLOBs, and we had to learn to parse them from the read logs. And LogMiner is generating anonymous PL/SQL blocks with I think binary like base64 coding for those objects, and it's again fucking slow, and maintaining the output of LogMiner was really awful. So LogMiner was awesome tool for us to learn the structure, to understand what's going on, but it's a not good idea to use it for some kind of productional load. Yep. Excuse me? DDL. DDL is not supported yet. Okay, so firstly, we focused on satisfying actual, concrete needs of this one customer. So when I will be sure that it works, the first version that we will put on a GitHub with source code and everything will be tested against 12.102 database, real application clusters, source ASM, with number, date, timestamp with time zone, CLOB, BLOB, in AL30, in UTF-8, AL32, UTF-8. Okay, so we will put this as a base and then add another functionalities over time. One of the functionalities we want to add, for example, is masking data on a flight from, for example, production system or test system to the development system, to have a possibility to add masking and pseudo masking for to the replication and leave it to the appliance. I can't see you. Ah, okay. Okay, that's it. If you will have any more questions, I'm here. I'm here till tomorrow. I will be here today evening drinking. So